Welcome to Summarize Science. Have you ever tried to get an AI to generate a huge, detailed image, only to get something blurry or with weird, repeating patterns? Well, researchers might have just found a way to give our existing AI models a massive, free upgrade for creating ultra-high-resolution art. This is DYPE, and as you can see from these comparisons, the results speak for themselves. The core problem is that the AI models behind these images, called diffusion transformers, are incredibly expensive to train on large images. The computational cost doesn't just double when you double the image size, it can quadruple or more, making it almost impossible to train directly on 4K or higher resolutions. The breakthrough came from a simple observation about how these AI models actually think when they create an image. They don't build it all at once. Instead, they follow a process called spectral progression. Think of it like an artist first sketching the broad shapes and composition. These are the low-frequency details. Then, over time, they fill in the high-frequency details, like texture, hair, and other fine lines. This chart shows exactly that. The big-picture stuff at the bottom gets locked in early, while the fine details at the top evolve throughout the entire process. Previous methods tried to just stretch the AI's understanding of space to fit a larger canvas, but that's a one-size-fits-all approach that often fails. This is where DYPE, or dynamic position extrapolation, comes in. It's a clever, training-free method that dynamically changes how the AI perceives space during generation. Early in the process, when the AI is focusing on those big, low-frequency shapes, DYPE helps it get the overall structure right. Then, as the generation continues and it's time for the high-frequency details, DYPE shifts its focus to help the AI nail the fine textures. It perfectly matches the AI's internal workflow without any costly retraining. And the results are staggering. Looking at the data in these tables, across multiple benchmarks and resolutions, the DYPE method consistently outperforms the older approaches. Whether it's matching the text prompt, looking more aesthetically pleasing, or just overall image fidelity, DYPE comes out on top. We can see it clearly in these side-by-side comparisons. Where older methods might repeat textures or lose detail, DYPE generates coherent, detailed images at massive resolutions like 4096 by 4096 pixels. The researchers even conducted a human study, and participants overwhelmingly preferred the images generated by DYPE by a margin of nearly 90%. So, let's recap the important points. The big problem is that training AI on ultra-high-resolution images is wildly expensive. The key insight is that AI models build images from broad strokes to fine details in a process called spectral progression. DYPE is a new, training-free technique that dynamically guides the AI through this process, allowing it to generate incredible high-resolution images from models that were never trained for it. What does this mean for the future? It suggests we can unlock the hidden potential of our current AI models, allowing them to create massive, print-quality art, detailed architectural visualizations, and more, all without the huge cost of retraining. It's a powerful and efficient upgrade that could change the game for high-resolution AI generation. Thanks for watching Summarize Science.